Okay folks, so some time ago I said I'll post a video on my prototype for home automation using ESP8266. So you see the ESP8266 here, which is sitting on this board. This is a home fabricated PC board, and this is the low voltage circuitry on this side, and the high voltage switches on this side, which can switch 230 volt loads. There are actually two switches here. They are two triacs, and they both are connected to these two connectors respectively. So you see the AC input line coming into here, and these switches actually switch this input line to the loads. So on this side you will see this connector here, which is actually a connector that takes ESP8266 transmit receive signals and connects it to a TTL converter, which makes it compatible with a USB line, and that USB line is connected to a USB port on my Mac. And one of the load points here is connected to an LED bulb. So that is the whole setup. As you can see, I'm going to try and show the bottom PCB layout side of this board. So this was home fabricated, as I said before, by buying a blank PC board and transferring the PC layout diagram onto this board and etching it using ferric chloride and hand drilling all the holes that are required to place the components and finally solder them in place. So that's basically a description of the ESP8266 board. Now you see the system is powered up. The LED on ESP8266 is on, and if you go a little bit further, the TTL converter USB adapter is also on, and our system is therefore now live. Now come here to the Mac. You see that there is a program that is here, and this is the program that is coded onto the ESP, and when we actually switch the window and go to the browser, here is the interface. So it's actually implemented as a RESTful API from a browser. If you send a command like this is the IP address of the ESP. If you say switch on pin 1, it goes on, and you just watch the LED light. I'm going to switch it off and it will go off. So whenever it does the action, it also sends a response by saying whether the status has been successful. The action has been successful, and it also sends data about both the loads that are on the ESP, whether they are on or off. We have not connected anything to load 2, but if we do connect anything to load 2, and that load will also be on right now. That is the basic interface to the ESP8266. The ESP8266 program, which I showed here, is the server that is doing all this. So we will actually go to the next step and then see how we can control the ESP8266 from a mobile phone. Okay, now we introduce a Raspberry Pi into the home automation solution. Here is the Raspberry Pi, and it actually runs a web server which has been programmed by me using Python and Django, and this web server actually can control more than one IoT board, as you can see here. So this is one board. So this server that I showed just now, which is right here, it connects to the same LAN as the IoT board, and on that same LAN you can connect any number of IoT boards, and this one server can control each one of them. So the web application that I wrote using Python Django, I'm just showing it on my desktop. and you can see that when I switch here using my mouse, this device actually goes on or goes off. Okay, so this web application is actually a responsive web application. So when I use it on my mobile phone, it would actually show up very nicely on the mobile phone, just like a mobile app. I have not had the time to sit and write an iOS application and an Android application, a native mobile application for these mobile phones. So I decided to use a responsive web application, and let me show it to you using a mobile phone. Okay, now you see the web application that's showing up on a mobile phone, and when I switch it on here, the load switch is on. Switch it off, it goes off. That's all, folks.